Okay, today's assignment, we're looking at quadrilateral properties chart. This notes page, I'm just going to go ahead and fill these blanks in. You can copy them down if you don't have that yet. I'll do as much as I can and scroll down. We're not really going to address it a whole lot, but we will as we progress through this unit. Just make sure you get this copied down correctly and you have the right properties. The first one, well, see, there we go, I made a mistake. The first one we're going to do, we'll be looking at parallelograms, which will be tomorrow's lesson. So this is first for all the figures. And I'll show you which ones, what the labels for each ones are. We have parallelogram, rectangle, rhombus. I'm saying these so that if you can't read my writing, you'll know what it is. Square, isosceles, trapezoid, and then a kite. Okay, a couple things. If parallelogram is a quadrilateral with two pairs of parallel sides. That's what it is. That's two pairs of parallel sides. A quadrilateral is a parallelogram. Then, if we say that if it's labeled as a parallelogram, then these are things that we know to be true. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. That means they add up to 180. These would be consecutive angles. They would add up to equal 180. So parallelogram has opposite sides parallel. Opposite sides are congruent. Opposite angles are congruent. I'm going to stop writing things there before the picture looks too crazy. And consecutive angles are supplementary. If a parallelogram has one right angle, then it has four right angles. If one of them is right, it's going to have, there means it's that four are right angles. And it is a rectangle. The one other part I would like to mention down to you, we're going to skip that proof. But if a quadrilateral is a parallelogram, then the diagonals bisect each other. Which means if I have got a parallelogram, the diagonals intersect at a point that splits the other diagonal into congruent segments. That's what we mean by bisecting each other. Looking at some examples here. Okay, if angle B is 32, CD is 80, and BC is 15, what is the length of AD? Well, AD is opposite BD, and we already said opposite sides are congruent, so segment AD is also 15. The measure of angle C is, remember, you see B and D, or B and C? They are what we could call consecutive sides, and consecutive sides are supplementary. That means 32 from 180 will give me angle C, which is 148. So angle C is 148. The measure of angle D, remember we said opposite angles are congruent, so B is opposite D, means they're congruent, so the measure of angle D is also 32 degrees. Okay, we have parallelogram now down below. We've got to solve for R, S, and T. Looking at R, look at this segment. It is opposite this segment. That means these two segments are congruent. So 4R equals 18. And we can now solve for R. R equals 4.5. Now angle or segment S. S is 8S here is equal to this. This segment is 7S plus 3. Remember, this is a parallelogram, therefore the diagonals bisect each other. So 8S equals 7S plus 3. Subtract 7S and S equals 3. Okay, and then the last one, we have this angle equaling 2t. Now we haven't talked about this, but if these are parallel lines, and this diagonal could be called a transversal, then this angle that's 2t is congruent to this angle that's 18, because alternate interior angles are congruent. So now we just divide by 2 to solve for t, and we get 9. And that's my answer. Next example is just like that one. In fact, it's almost identical. Opposite sides are congruent, so 2p equals 22. P equals 11. We have this segment equal to this segment. Diagonals bisect each other, so 6x plus 2 is equal to 4x plus 12. Subtract 4x, we get 2x. Subtract 2, we get 10. X equals 5. Slow it down if I went too fast on that. And then the last one again, we have those alternate interior angles. This angle is congruent to 25 because of alternate interior angles. 3k plus 4 equals 25. 3k equals 21. K equals 7. Number 6, it says that here we have a parallelogram A, B, C, D with these coordinates. We need to find the intersection of the diagonals. These would be the diagonals. Well, remember, they bisect each other, which means the point of intersection is actually the midpoint of either of those two segments. So let's work with AC. We're going to take A, we're going to take C, and we're going to use the midpoint formula. Midpoint formula, recall, where we add the x's, negative 4 plus 4, and divide it by 2. That's going to be my x-coordinate. Then we add the y's, 6 plus negative 2, divided by 2. We end up with 0 over 2, which is 0, and y is going to be 4 over 2, which is 2. I don't have to do dB because I know that it's a parallelogram, so the midpoint of dB is also going to be that. That is my answer. Number 21 on the homework is just like this one, so you're going to use the midpoint formula for number 21. Just find the midpoint of one of the two diagonals, and that's it. You do not have to do number 13 and 14 since they're unreadable on your assignment. But other than that, you should be good. Oh, I will say this. Let me look at number